Hello, Algebra 1. I am looking at section 6.1 of your student journal. This is on page 172. So if you want to follow along, you can. I'm going to do a few examples to help you with your homework. I'm just going to pick like 5 or 6 of them to go through so that you can see some of these problems being completed. You can watch some of this video or you can watch all of this video. It is up to you. Watch as much as you need in order to understand the material. Okay, so looking at these problems here, let's start with numbers 1 and 2. Looking at numbers 1 and 2, these are very easy. These are taking a base of 3 to the power of 0, a base of negative 2 to the power of 0. Anything to the 0 power is 1, so both of these equal 1. That is your answer. A negative exponent. Remember, we don't want negative exponents in our answers. Oftentimes, if you look down here, it'll say write your answer using only positive exponents. Looking at number 3, it says to evaluate the expression, which means to find the value. That's really what it means. So I'm going to go ahead. I cannot expand a negative exponent because you can't write something out negative 4 times. So I'm going to make it positive. Remember, if it's in the numerator, meaning you can write it over a 1, to make it positive, you take the base of the negative exponent and you bring it to the denominator. That becomes 1 over 3 to the 4th power. 3 to the 4th power is 3 times 3 times 3 times 3, which is 9 times 9, which is 81. So you get 1 over 81. I'm running out of room here. Squeeze it in. There it is. All right, let's look at another one. If I look at number 5, on number 5, I can see I have 5 to the 0 power in the denominator. Well, that means that this is a 1. It cancels out. So what you're really left with is 2 to the negative 3 power, which this turns into a problem just like number 3. To make that exponent positive, you bring it down to the numerator. It becomes 1 over 2 to the 3rd power, which is 1 over 8. So hopefully you're understanding what is happening here, okay? All right, let's go down to these ones down below. These ones are a little bit more complicated, okay? So for example, let's see. Let's do number 15. For number 15, we have the same base. So if you have same base and you're dividing, you can just subtract those exponents. So it's 3 to the 5 minus 3. Remember, top minus the bottom. That's going to give you 3 squared, which is going to give me 9 as my final answer, because 3 squared is 3 times 3. Another problem to look at could be something like, let's look at number 11. I'm really not doing in these in no particular order, okay? So then we have a to the, I can see here what I have is I have 6 times a to the 0 power times b to the negative 2. So this will sort of, if you think about it this way, it helps a little bit because a to the 0 power is going to be 1. So really what you have there is 6 times 1, which is 6 times b to the negative 2 power. Remember, in order to change this to a positive value, it needs to go to the denominator. You only move the bases that have a negative exponent. Well, 6 has an exponent of 1. Remember, that's not written there. Don't move it. It's a positive 1 exponent. It's fine. But the base of b has a negative exponent. So that needs to go downstairs. So if you think about this being over 1, the only thing that's going to move to the denominator is b to the negative 2. The 6 is going to stay where it's at. So that's going to become 6 in the numerator all over b to the positive 2 power, and that's as far as you can go. Okay, looking at another example. Okay, here in number 17, we have a same base of negative 5 being raised to the 3rd power times negative 5 to the 3rd power, right? Remember, if you have the same base, you can keep that base and add your exponents. So 3 plus 3 is going to give you 6. So negative 5 to the 6th power, You might want to take out a calculator for that one if you don't know what it is. So that's 5 times 5 times 5 times 5 times 5 times 5, right? So it's a big number. So 125 times 125, 15,625. Okay, now the answer to this is going to be positive. The reason it's going to be positive is because the negative is contained within the parentheses, and when it's contained in the parentheses, that means that you're multiplying 6 negatives to each other, right? And for every 2 negatives, it becomes positive, so positive, positive, positive. So it ends up being a positive final answer. Okay. So then I can go to yet another example. If I look at number 20, in number 20, again, I'm going to simplify this one a little bit different. I'm going to start with the numerator. If I have the same base, I can add those exponents like that. And then I have this c to the 6. And again, if I have the same base, I can subtract, which becomes c to the first power, which is just c. So sometimes these take more than one step. A lot of times we cannot answer the problem with just one step. Okay. All right. Number 21. Number 21. You have a product to a power. When you have a product to a power, we need to remember that every exponent on the inside needs to get multiplied to the exponent on the outside. So you end up with -4 to the 4th power times d to the 4th power. -4 to the 4th power is just -4 times -4 times -4 times -4, which essentially is just 16 times 16. That's how I like to think about it. If you don't know 16 times 16, you can punch that into the calculator and you get 256 d to the 4th power. There it is. Number 19 is pretty simple. It's power to a power. Power to a power rule means that you multiply those exponents. So I get a to the -8. And remember, no negative exponents. Since this is in the numerator, to make it positive, you're going to bring it downstairs. And it's going to be 1 over a to the 8th, if I could say that correctly. Okay. Looking at number 23, this is a quotient to a power. Remember, everything has an exponent, even an exponent of 1. So what I'm going to do is I'm going to make sure to multiply that outside exponent to every exponent on the inside. So that's going to be 4 to the -3 over x to the -3. Both of these have a negative exponent. For both of these, they kind of got to switch places. This one's got to go down. This one's got to go up. And by changing that position, it's going to allow that to become positive exponents. So I get x to the 3rd all over 4 to the 3rd power. And 4 to the 3rd power is 4 times 4 times 4, which is 64. So that is your final answer there. Okay. Let's see. Any other examples that are good? Number 14 looks like a lot. I don't really have enough space to do it there. Let me do that one over here off to the side. So if I have 2 to the 3rd, a to the -3, all over 8 to the -1, b to the -5, c to the 0. Okay, so this is number 14. All right, first thing I'm going to do, I like to look for my 0 exponents. 0 exponents are going to become 1, which means they're going to cancel out because it's multiplication, right? 1 times any of that will just give you any of that. The other thing I like to do is move my negative exponents if I can. So finding the bases with negative exponents. Bases with negative exponents, I like to circle those. So let me, base of a has a negative exponent. Base of 8 has a negative exponent. Base of b has a negative exponent. Base of 2 has a positive exponent of 3. Leave it where it's at. So what I'm going to do is I'm going to move those. 2 to the third stays where it's at. These are going to move. It's going to be times 8 to the first times b to the fifth. By moving them to the denominator, it makes those exponents positive. Remember that this is canceled out because it's 1, so the 0 power is 1. A to the negative 3 is coming downstairs because it needs to be positive. Let's simplify this a little bit more. 2 to the third power is 2 times 2 times 2, which is 8. 8 to the first power is just 8. And then I have b to the fifth, and then I have a to the third down below. You cannot subtract the exponents here because the bases are not the same. 8 times 8 is 64. B to the fifth stays where it's at. A to the third stays where it's at. And that's as far as you can go with this problem. Okay, so I tried to incorporate a whole bunch of different examples for you. I just want to touch on one more example, and I guess we'll do number 7. So for number 7, what you'll notice about the denominator is that it says negative 7 to the 0 power. If the negative is not contained in a parenthesis, it's going to give you a different answer. When you have a negative without the parenthesis, like you see here, that really means that you have a negative 1 times 7 to the 0 power. I know it's really tricky to realize that, but just know that with the parentheses there, the negative is contained with the 7. With no parentheses, you want to think of that negative as being separate. Only the 7 is being raised to the 0 power. And that's one thing that's really tricky. So, for example, negative 7 to the 0 power without parentheses is actually going to be negative 1 times 1, which is negative 1. Negative 7 to the 0 power, if it were contained in parentheses, would just be 1. So in looking at number 7, what I'm left with is 4 to the negative 1 in the numerator and a negative 1 down below. Okay. Remember, this negative can be put anywhere when it's with a fraction. Oftentimes with a fraction, I like to put my negative in the middle right there. And it means that sort of look like this. Right? So the negative can be anywhere. Okay? So we can go ahead and take that for the negative 1 and bring it down below. And it becomes negative 1, because there's nothing left in the numerator, so there's a 1 there, and then it's 4 to the first, which is just 4. And there's still that negative there. You could have had 1 over negative 4. That's fine. Just know that with a fraction, like negative 1 over 4 with it in the middle, that negative can be in the numerator. It could also be in the denominator. It doesn't matter. Oftentimes, I like to stick with one of these two options. Sometimes I just put it out in front, in the middle. It makes it a little bit easier. So this is what you get here. Okay. And so there's, another example for you to look at. So there's a few more problems on here. I'm not going to do all of them, but I hope that this gives you enough of an idea of how to do different types of problems. Now, every problem is different. There is no way that I can show you every single type of example that's out there. The idea is to take the properties that you are given and apply them to these problems in order to simplify it. Okay. So I hope that this helps, and best of luck with your practice.